Welcome to Thought Control, and today we will state So, do you know the Sun is classified as a yellow dwarf? The Sun is classified as a G-type yellow dwarf, which is a little misleading as stars in this sequence can vary in color from yellow for cooler stars to white for the hotter ones. In actual fact, our Sun is just under halfway through its almost 10 billion year life cycle and is white in color. On Earth, we see the Sun as either yellow, orange or red, as these are the colors of the longer wavelength lights which make it through our atmosphere. This process is why the sky appears blue, as shorter wavelength lights such as blue and violet are absorbed by the atmosphere, thus giving it its bluish hue. The Sun is the biggest object in solar system. The Sun is the hottest, biggest, most massive object in the solar system and contains more than 99.8% of the solar system's mass, with Jupiter accounting for more than 80% of the remaining 0.2%. Sun's gravity keeps solar system together. We also know that the Sun's immense gravitational field keeps the planets from flying off into space, with its gravitational pull at the equator 274 meter per second square, or 28 times more powerful than the Earth. To put this in perspective, if you weighed 90 kg on Earth, you would weigh 2520 kg on the Sun. The Sun is almost spherical in shape. Volume of the Sun, it is remarkable that an object almost 1.4 million km across has polar and equatorial diameters which differ by only 10 km. This fact makes the Sun the closest thing to a perfect sphere yet discovered in nature, and if the Sun was shrunk to the size of a beach ball, the difference between its widest and narrowest diameters would be less than the width of a human hair. Our Sun generates winds and flares. The Sun generates roughly 386 billion megawatts of energy through nuclear synthesis as it converts hydrogen into helium. This energy travels outward from the core and is continuously absorbed and re-emitted at progressively lower energy levels and temperatures until it emerges from the surface, where some of it becomes visible as optical light. Some of the Sun's energy is then radiated as heat, but it also powers a stream of energetic particles that is perhaps better known as the solar wind. Sun has simple chemical composition. The Sun consists of only a few elements, of which hydrogen is predominant at around 72% and helium at about 26%, with the other elements accounting for progressively smaller amounts such as oxygen, carbon, neon, nitrogen, magnesium, iron and silicon. Magnetic field up to 3000 times stronger than Earth's. Although the Sun's magnetic field is only about twice as strong as Earth's overall, the differential rotation of the Sun concentrates the field in some places where it can be as much as 3000 times as strong as on Earth. Magnetic concentrations manifest as sunspots and only occur up to about 45 degrees north and south of the solar equator, because it is in this region that the differences in the rotation rates of different parts of the Sun is greatest. The Sun has reversible magnetic field. Sunspots can number from 0 to about 250 plus during each 11-year period, after which the Sun's polar magnetic field reverses its polarity. This cycle, however, is not constant and it varies with overall magnetic activity. Sun has an internal structure. While the Sun's core takes up the inner 25% of its structure and accounts for 2% of the Sun's total volume, this region contains close to 50% of the Sun's total mass, given the fact that it is 15 times dense as lead. The next most massive area is the radiative zone that extends from the outer edge of the core to roughly 70% of the way to the surface. This region accounts for 48% of the Sun's total mass and 32% of its total volume. Photons created in the core get bounced around in the radiative zone so often that on average it takes them about 1,000,000 years to reach the surface. Further from the Sun, the hotter it gets. Common sense dictates that the further one moves away from a heat source, the cooler the ambient temperature should be, but the opposite is happening on the Sun, that is, the further one moves away, the hotter it gets. This was first noticed as far back as 1939, but recent research seems to have solved the mystery. Stay tuned for more such videos.